Okay, so page 355. What I'd like you to do, no, Tran is not the best. Okay, how did that pop up? I would like you right now to expand these. Remember, expanding means to use FOIL, multiply it out. So these two, can you please expand on your own? Let me know if you need help. Okay, first times first, right? FOIL, 6x squared. Then you're going to have a 4x. 6x squared, we had a 4x, a 3x, and a plus 4. So once you collect your like terms, you should have 6x squared, oh that's 8x, plus 11x plus 4. When you collect your like terms, yes? Okay, so what does that mean? That means that if we 6x squared plus 11x plus 4 factors to 2x plus 1 times x plus 4. So let's do the same thing, but for the next one. 3x times 4x is your 12x squared. The 3x times the 3, 9x. Negative 2 times positive 4, negative 8x. So when we collect those like terms, we're going to get plus x. And then negative 2 times positive 3, negative 6. So that means 12x squared plus x minus 6. Okay, so when you expanded, you probably had 12x squared plus 9x minus 8x minus 6. And then we collect our like terms, right? So what we're going to do is that today. We want to factor. So how do we turn a trinomial that's type 2? So what's a type 2 trinomial? A type 2 trinomial is also known as a complex trinomial. And that's when our a value is not equal to 1. And by a, I'm referring to ax squared plus bx plus c. Okay? So it's not equal to 1 and there is no GCF. We can't pull out a. So what do we do in those situations? Those are a little bit more fun. Okay, let's review from last day grouping. Do you remember grouping when we had 4 terms? Group the first two. What can you factor out of the first two? 3 and x. And we're left with what? 2x plus 1. How did I do that? Okay, so I look at the first two and I see, okay, what can I divide both by? Right? I could divide both by 3 and an x. So I'm going to put that 3x in front of the brackets. And then we divide to see what's left over. Okay? And so if you work backwards and expanded with distributive law, you should get back to where you started, 6x squared plus 3x. So the other two, what can we divide both of those by? 4. So I'm going to put what in front of the brackets? Plus 4, because this was addition. And what's left over when we divide? 2x plus 1. Our last step, factoring out the binomial. So we have 2x plus 1 in common. When we factor that out, what are we left with? 3x plus 4. Okay, now you try 2. Okay. Yep. Minimize. My thing is not oriented right. Like this. Okay. So So what did you get here? What could you factor out of the first two? A 3x. And when you divide both by 3x, what's left over? 4x plus 3. What did you factor out when you grouped the second two? What did you factor out? Good, -2. If they're both negative, or if the first is negative, we factor out the negative because we want to be left over with the same thing. So what are we left over with? 4x plus 3. And last step, you should have factored out the 4x plus 3, left with 3x minus 2. Okay? So that example that's at the very top of the page, we just jumped down, we're going to look at really quickly. So I want you to look at the top. And it says algebra tiles, but I'm going to write instead with traditional decomposition. So I'm going to show it to you once, but we're probably not going to use it. But I do want to show it just in case you like this. Okay? So this is one method. So traditional decomposition, we want to factor a complex trinomial. Remember yesterday, this was just a 1, but today it's a 5. Okay? So this time, my product is going to be the product of the first and last. I want two numbers that multiply to 10 and add to still the middle term, which is 7. So when I look at, so this is first times last, or A times C. If we think of it in the terms of x squared plus bx plus c. Okay? Is this large enough at the back, or should I zoom in? Zoom, I bet. Okay? Yeah, what's your question? Yes, only for the traditional. Okay? Only for the traditional. You can, the other method, the Chinese method, I'll show it to you in a second. Just hold tight, because that's probably what we're going to do. But I do want this in your notes, just in case you do prefer this, okay? So what are the two numbers that multiply to 10 and add to 7? 5 and 2. So just like yesterday, we're going to break up the middle term. 5x squared plus, instead of 7x, we're going to write uncollect like terms, so it's going to be 2x plus 5x plus 2. And now that we have 4 terms, we do what we just did. We did grouping. Okay, the first two, if we group together, what can we factor out? An x. We're left with 5x plus 2. What can you factor out of 5x plus 2? Instead of nothing, actually, it would be just, you're going to write plus 1. The only common factor is 1. You can only divide those both by 1. The only thing that's in common. And we're still left with 5x plus 2. And then we write our final answer by factoring out the 5x plus 2. We have x plus 1. Okay? So that's the traditional method. That's one method. Okay? So one method is traditional method. What's another method? Well, let's go back a page. How about algebra tiles? That's also a method. We'll get to it. We'll get to your method in a second. But let's just quickly do one question with algebra tiles and then move on. So we have how many x squareds? 2x squared plus how many x's? 7. How many ones? 6. Okay. So let's factor that. Let's make a rectangle. So if we want to draw a rectangle, the x squareds have to go beside each other. So either one beside it or one below it. Let's do beside. So we have 2x squareds beside each other. Now we want to place our x's. So you're going to place our x's beside and below. However way that is. I just started randomly drawing it. So that we get, remember, in the corner is our ones. And we want to have 6 ones. Okay? You want to give it a shot by yourself? See if you can draw it? Or do you need help? Start with putting one x over here. and 2 x's along the side here. Okay, how many 1s would that fit? That would be 3 x's and 1. We want 7 x's and 6 1s. So we need to draw more. Okay, 2 more on the bottom. And 2 more on the side. Does that give you 6? Yeah, we have 7 x's and that's 6 1s? Sure is. Braden's a genius. Yeah. It's on recording, too. Yeah. So the question was, what's the dimensions? What's the dimensions there? 2x plus 3 times, what's the dimensions on the other side? At 1x plus 2. Okay, so algebra tiles is a method you can use. You need a lot of paper, and you have to be like truly in love with just drawing the algebra tiles. So what about the third method, which is most of your favorites method? Let's go to the Chinese method. Okay, so let's go to number 3. Number 3. So the Chinese method. You can also call it guess and check. Kind of is guess and check. So now we have a 2. Is there a GCF? Always check GCF. Is there one? Nope. 2, 7, and 6. 7's prime, so definitely not. Okay, how can we multiply to 2? 1 times 2. Okay, this is the fun part. Now, 6. How can we multiply to 6? 1 times 6 and 2 times 3. So which one do you want to try? Okay, let's try 1 and 6. Now remember, I'm going to first go 1 and then 6. The diagonals, the product of the diagonals should make our sum of 7. What's 2 times 6? Oh, okay, let's flip the 1 and 6. So that's not going to work, right? It's the same thing, right? You always put the 1 on top. Okay, let's put the 1 on top. 1 on top. And then you're saying do instead 6 and 1? No, 1 and 6?
1 and 6.
Okay, that 1 times 6? 6. 2 times 1? Does that add 7? No. Okay, so we tried switching 1 and 6, so we have to throw that away. We're going to try now what? 2 and 3. 1 times 3? 3. 2 times 2? 4. Does that add to 7? Yes. It's a little bit more tricky when it's complex. Okay, so now we throw our variables in. And what's our solution? X plus. Remember it's straight across. So this is one factor. This is the other factor. X plus 2 times 2x plus 3. They are both positive. Good. Okay, 5x squared plus 7x plus 2. GCF? No. Okay, how do we multiply to 5? 1 and 5. You like your 1 first. We'll put the 1 first. Just for you. How many ways can we multiply to 2? 1 and 2. This is nice because we only have 2 options to choose from. Let's try 1 and 2 and then see if that works. 1 times 2? 2. 5 times 1. Does that work? Does that add to 7? Yay, we got lucky. Okay, so we can throw in our variables. And what were the signs here? They are both positive because we are multiplying to a positive, adding to a positive. So our answer would be straight across. X plus 1 times 5x plus 2. Not so bad? Not so bad. Let's try 4.
Wait, so like just factor and decomposition are the same thing?
Factor and decomposition are the same thing, yeah. It's usually they'll say factor by decomposition. It's a method of factoring. Yeah. No. So whatever you like, stick with it. Yeah, I'm not going to say, yeah, you could use this method every time. Even when we had 4 terms, you could still use this method because you collect the like terms and now you have a trinomial. So going back to that question we did earlier here, somewhere. It was somewhere. There you are. So if instead of using grouping, we could collect like terms and now factor your traditional way. 3 and 2, 2 and 2 we could try, right? Okay, that gave me 6 and 4, which is 10. That didn't work. Erase, right? So we still can use this method. You didn't have to use grouping. Just make it into 3 terms and then traditional way. Okay? All right, so going back to number 4. Do you want to do this one together or by yourselves? Together. Okay, good. 6 and 1. For 6, you could do what way? 2 and 3 or 1 and 6. Which one would you like to start with? Sure, 2 and 3. Okay, how can you multiply to 3? Okay, so we'll worry about signs after, but 1 and 3. Okay? Because we might want to put the -1, it might be -3.
Doesn't that add up to 17?
It does. So is this going to work? No, just by looking at it, you know, 6 and 3 adds 2. So, well, we're going to actually end up different. There's no way to make 17 out of those, even if we play with the signs. So you could try switching 3 and 1. Don't give up on those yet. Switch the 3 and 1. Is that going to work? No, because I get 9 and 2. There's no way to make 17 out of those two numbers. So what needs to change? The 6 and the 1. We need to actually change 2 to 3 to 6 and 1. Or you like 1 and 6, right? Sure. Okay, does that work?
No, that's equal to 19.
Yeah, -1.
Ah, -1. 6 times 3. Remember, we want to make a -3 product, positive 17. So we can make 17 if 1 is negative. Agreed? Yeah? That would give it 17. Now we just always double check. This should 3 and -1 multiply to -3, yes. 1 and 6 multiply to 6, yes. So we're good. What would be our answer then? X plus 3 times 6x minus 1. Good. Together or separate? By yourselves or together? Together? Let's do together. How can you multiply to 3? 3 times 1, or some of you like 1 first, so we'll go 1 and 3. Okay, 8, we have a few options this time. 1 and 8, 2 and 4. Where do you want to try? Okay, 2 and 4. Okay, does that work? 1 times 4? 4, 3 times 2, 6. Now remember, we're multiplying to a -8. We want to multiply to a -8. So one of them is going to have to be negative. Which one's negative? We want a -6 to make -2. Agreed? So it would have to be a -2. Are you with me?
Oh, do you always have to add in the end?
These two you always add together, but you have to make sure their signs are correct. Yeah. Yeah. And they have to make the middle term. Yeah. Okay, so and then you're comparing, double check. Does -2 times 4 equal -8? Yes. And then you also double check, does 1 times 3 equal 3? Yes. Yes. Okay, so our answer is x minus 2 times. Good catch. And I know I do this. N minus 2 times 3n minus or plus 4. Good. On your test, if you put an X instead of an N on a written response, I'd still mark it right.
Well, you put that also on my test because I wrote like that.
It depends. That was different on expansion. Factoring expansion, because you're combining, depends if you're combining like terms. Then I'll take a look at it if you want to show me. But yeah, we'll talk. Okay, 12. What do you want to try? 2 and 6? we have options. 2 and 6, 3 and 4, 1 and 12. Yeah. The nice thing is what? That 1 only multiplies to 1 by 1 and 1. Now we're multiplying to a positive, but we're going to add to a negative. So both our signs have to be negative. Is this going to work? 2 and 6, can we make 8 out of that? How can we make a negative 8? If both the ones are negative, that would make both our products negative. That would work. Sorry, is that better? Okay, double check. Negative 1 times negative 1, is that positive 1? Yes. 2 times 6, is that 12? Yes. Okay, we're good to go. What is that factor to? 2x minus 1 times 6x minus 1. Good. All right, are you ready to try one on your own? Sure? Okay. Oh. Okay, do you want to try? Let's do A together, then you're going to try B, okay? So A. Because, well, you could try it if you want. It's just backwards. Is that okay? Yes. As long as it's in your trinomials, always either have to be an increasing order of degree or decreasing. Because in that form, we're always using the product of the y squared and then the product of the constant. Right? So that's why. So this one, how can we multiply to negative 2y squared? So either one of them, so 2 and 1 or 1 and 2, agree? And are they both negative, both positive, one negative? One's going to be negative. We don't know which one yet. We'll put in our signs later. Multiplying to 15, what do you want to try? 3 times 5. Okay, 3 and 5. Let's see if this will work. 3 times 1 is 3. 2 times 5, 10. If they're opposite signs, is there a way to make this a negative 7? Yeah, so that the 10 is negative, meaning that the 2 would have to be negative. That would make a negative 7. Yay! Okay, so where's your variables going this time? With the 3 and 5 or 2 and 1? Because we want to make a y squared, it's with the 2 and 1. So our product actually looks like what? You could write it as negative 2y plus 3. Could you also write it as 3 minus 2y? Yeah, it's the same thing. Okay, and then 5 plus 1y, or y plus 5. It's the same thing. Brayden, can you put that in the bucket? Inside there, yeah. Thank you. Okay, B, where do we start with B? Go over this way. No, the order's okay. Do you spot? What do you see? Common factor. Is there a common factor this time? Yes, what is it? 5. 5. Okay. Yay. What are we left with? You guys have had too much candy today. A lot of you are crashing hard.
I had one too.
Oh.
It's just Friday.
I'll change that soon. Okay, so what's left over? 3k squared plus k minus 2. That's way more animated. Thank you. Yay. Now, that makes it a lot easier to factor because how can we multiply to 3? 1 and 3. How about 2? Okay, we'll either try 2 and 1 or 1 and 2. Now, we know that 1's positive and 1 is negative, right, Brayden? Okay, what does this multiply to? The diagonal here. 2. And this one? 3. Is there a way to make 1 out of that? If 1 is positive. And 2 is negative. So positive, negative. That would do it. Okay, so what is this going to factor to? Be very careful. Put the GCF in front. Don't forget. And we're left with k plus 1 times 3k minus 2. And then the 5's in front. Not so bad? No. It's not a big jump from yesterday, right? Can you try A? Give it a shot. I'd like you to try A for the next page before we start your homework. So it's the same idea, even if you have x squared minus xy plus y squared. Okay, guys? Okay, so 2 and 1, and then 1 and 2 is how we're going to have to. The reason why 2 times 2 is 4. 1 times 1 is 1. They have to both be negative because we want to multiply to a positive 2 here, but add to a negative. So they both have to be negative, and that's the only way you'd add to a negative 5. All right? When we have those negatives, it's a lot trickier. Now, we put in our variables. 2 and 1 have to multiply to 2x squared. So what's the variable there? X and x. And on this one, we have to multiply to negative 2y squared. So what's the variable? Y and y. So there's our factors. 2x minus 1y times 1x minus 2y. Okay? Let's try one more. Do you want to give it a try now? Try B. Same idea. Okay. So, I'm just going to interject here. Okay, to multiply to 2, 1 and 2. 15, we can do 1 and 15 or 3 and 5. I'm going to start with 3 and 5. Okay, so I'll try that. 5 and 6. Does that work? No. This is where an eraser is helpful. So I'll switch 5 and 3 and see if that works. Now I know it's a negative 15. So it's going to be 1 positive, 1 negative. 3 and 10. Hey, if they're opposite signs, can I make a negative 7? Yes. Okay, in my sum, who's going to be positive, who's negative for 10 and 3? 10's negative. Positive 3 would make a negative 7, meaning who's negative? The 5, and the 3 is positive. Now, we put in our variables. What are our variables? N and N, and M and M. M and M. Okay, so your answer should have been N minus 5M, 2N plus 3M. Okay? So, this stuff's going to take practice. It's going to require you to actually sit down and work it out. Okay? Now, your assignment, let's talk about your homework. Okay? No, there's only 2. Okay. Where did I put it? So there's your assignment. Working